this is the 11th video in the CSES sorting and searching video series. In this video we will be solving the problem number 11, which is collecting numbers. So the problem statement is, you are given an array that contains each number between 1 to n exactly once. Your task is to collect the numbers from 1 to n in increasing order. On each round you go through the array from left to right and collect as many numbers as possible. What will be the total number of rounds? The first line has an integer n, the array size. The next line has n integers x1, x2, dot xn, the numbers in the array. And in output we have to print one integer, the number of rounds. Then constraints: n is greater than or equals to 1 but lesser than or equals to 2 into 10 raised to power 5. Then we are given an example case. So first let's try to understand the problem statement. So in this problem we are told that we will be given an integer n, and then we will be given n integers which are all distinct starting from 1 till n, and they will be ordered in any random order. For example, in this test case we are given n5, and then we are given all the 5 integers from 1 till 5, but they are not in sequence, they are in random order. And the task we have to perform is, we have to collect these integers, but in each round we have to collect numbers in increasing order only. So we need to we want to try to collect as many numbers as possible in every round, but the constraint is that we can only collect numbers in increasing order. And then we have to determine what will be the total number of rounds if we work in an optimum manner. Basically, if we try to collect as many numbers as possible in each round. So first let's try to understand the sample case. So in first round, let's say if we collect 1 and 3 in first round, and then we collect 2 and 5 in second round, and then 4 in the third round, so we can get answer 3. Now if we will try some other permutations as well. For example, if I collect 4 and 5 in first round, then 2 and 3 in second, and then 1 in third. So in every possible way we cannot get answer better than 3. So let's try to figure out what could be the possible approach for this one. So my values are starting from 1 and going till 5. 1, 2, 3, 4 and 5. And my indexes are, for 1 my index is 3, for 2 my index is 2, then for 3 my index is 5, for 4 my index is 1, and for 5 my index is 4. So whenever we are collecting numbers, if you will try to think, as we have to take numbers in ascending order only. So first whichever value we will take, take values which are greater than that particular value, and also their indexes should be greater. So can we say that, if let's say if we start from the first value, now if I start from the first value 1, because I need to collect my 1, and if and other than 1 in that round, in whichever round I will collect my 1, I can collect only those values in that round, the ones which comes later, which comes after 1, and which are also greater than 1. All those values which comes after 1 but are smaller than, obviously in case of 1 there won't be any value smaller than 1, but for any value we can only collect those values which comes after that value and whose indexes are greater than that value. So can we do it this way? We order the values, or we order the indexes basically according to the values. So now in this case, first index is 3, which is for value 1, then the index 2 of 2, then for value 3 the index is 5, so on and so on. Now in this way, can we start from here and find or figure out that after 1 can we collect 2? No, because now let's take third variable answer. Now initially we have to take at least one round is mandatory for us. In first round we can take 1, but can we take 2 as well in first round? No, because the index of 2 is lesser than 1. So for 2 we have to come in the next round. So can we say 2 will be taken in the second round? Then can we take third 3? Yes, we can, because 3 is greater than 2, so we can take 3 as well in the second round. Also, although you can also take 3 in first round, but that doesn't matter for us when we are taking 2 rounds. So if we are taking 3 in first round or second round, it doesn't matter much for us. So this won't affect the number of rounds that we are taking 3 in first round or second round. Then can we take 4 in first round or second round? No, we cannot, because 4's index is smaller than the previous one. So can I say 4 will be taken in the third round? Yes. Then can I take 5? Yes, I can take 5, because 4 is on index 1, so I can take 5 as well. So if you will think, we can simply sort our indexes based on the basis of values, then it's pretty easy that we will just keep on comparing the indexes for the current value and the previous one, and on the basis of that we will determine if the current value can be carried in that round only in which round the previous value was carried, or basically the current value can be collected in the round of previous value only. Then we won't be incrementing our answer, otherwise we will increment our answer. I hope everyone understood the solution. Let's try to code it out. So first we will take our n, then we will create our vector, instead of naming it v, let's name it index. This will store index for every value. For int is this one. So we will run this loop n times. Every time we will take one value as input, and then in our index, now we are using our values as indexes and in this particular array, and storing the I index for the value. So how we are behaving when for example when we are getting 4, so in our indexes array, at 4th index, which is 4 is our value, at 4th index we are storing the value 1, so that we can keep our indexes in this way, basically sorted as per the values. So we are sorting our indexes on the basis of values. After this, we can create a variable named answer, which will be initially 1, because you will take at least one round. Even if all the values are sorted, still you have to take one round. Then for integer I is this 1, I is lesser than n, I plus plus. So for every index we will check a condition that if now index of ith value, now ith value is obviously lesser than the I plus 1th value, because we are sorting our indexes on the basis of values. But the thing which we have to check is if index is also lesser. For I, the index is lesser than I plus 1, that means that after taking the value I, we can take I plus 1 because I plus 1 is, if index of I plus 1 is greater than index of I, that means I plus 1 is coming later, so we can take both of them in same turn. Otherwise our answer will be incremented. Now this case won't affect us, but if index of I is greater than, so basically this value's index is greater than the next value's index, that means our answer will be incremented because we cannot take the current value and the next value in same round as this value's index is greater than the next value's index. So that means this value will be coming later than the previous ones. So this value is although smaller than the next one, but as its index is greater, that means this value is coming after that value. So if 2 is coming after 4, once we have taken 4, we cannot take the 2. So this way we will keep on incrementing our answer. I hope it's clear to everyone. Then at last we will print our answer. Let's try to check it for the sample case. So we are getting output 3. Let's try to submit it. In CP, searching and sorting, problem number 11. Yeah, this one. Collecting numbers. So I hope this works. So our solution is accepted successfully. I have also started another video series on dynamic programming, in which I will be uploading videos on regular basis. So you can check that as well.